Hello guys, welcome to my channel. In this video, I'm gonna give you the one-shot video of the lesson Physical World of Class 11. If you're ready, let's get started. This lesson is actually for class 11 students to give interest among students in physics. Okay, so let's start. So science. Science actually came from the Latin word which means to know. Its meaning is to know. In Indian language, that is in Sanskrit, it is called as Vignan, that is knowledge. We all know, right? So, physics. What is physics? Physics deals with the study of natural phenomenon with the help of certain natural forces. With the help of certain natural forces, we will study certain natural phenomenon. That is called as physics. Next, we have scientific method. Scientific method involves certain steps, that is systematic observations, controlled experiments, qualitative and quantitative reasoning, mathematical modeling, prediction, verification or falsification of theories. These are the six scientific methods. Let me give a trick to learn this with the help of an experiment. That is, let's take the experiment of sun experiment. Okay, let's consider the experiment as sun experiment. So if you are going to observe the sun, first of all you should observe the sun, right? Yeah, first observations, then you have to experiment. If you are going to learn about evaporations, you have to experiment, right? That's experiment. Then you have to reasoning. Then if you are going to present that experiment at night, you don't have sun at night, right? So what you have to do? You have to do certain models, right? So you have to have a modeling, mathematical modeling, prediction, verification or falsification of theories. The one you have found about the sun may be true or may be false, right? So it is verified, and if it is true, it's okay, and if it's not true, it is falsification, right? So verification and falsification of theories. Clear? Next guys, we have two principal thrusts for physics. They are unification and reductionism. Okay, now let's learn about these two. What is unification? Small laws or principles can be combined and studied as a one single law or theory. Small law will be combined and studied. Okay, small thing will be grouped and studied. This is called unification. Then what is reductionism? We will split and study. Okay, complex theories, concepts are divided into small concepts for study. For example, the thermal physics, it's a broad concept. It will be separated, split, and they will study like thermal properties, thermodynamics, kinetic theory of gases. They will split like this and they will study. This is what we call reductionism. Okay. Next, we have the topic of scope and excitement of physics. There are two scopes and excitements. They are classical physics and quantum physics. These two terms are so interesting terms. Okay, classical physics and quantum physics. First of all, let's see about classical physics. Study of macroscopic objects, that means study of stars, planets, galaxies. Those are called macroscopic objects. Study of those objects are called classical physics. The branches here are mechanics, electrodynamics, thermodynamics, optics, right? Optics, we know, light. Yeah, study of light. Those things are. What are the branches? Mechanics, electrodynamics, thermodynamics, optics. This is what we call classical physics, study of macroscopic objects. Now let's go for quantum physics. Quantum physics, study of microscopic particles. So here we have seen classical physics. Classical physics is study of macroscopic particles. right? Macroscopic, this is macroscopic and this is microscopic. Classical physics is macroscopic and quantum physics is microscopic. That is, example, study of protons, neutrons, electrons. Electrons are also called as matter waves. Okay, study of these things are called quantum physics. Okay, next we have physical quantities. We know, right? Physical quantities, length, mass, energy, time. These are what we call physical quantities. Now let's see the ranges of length. Length is small as 10 power minus 14 meter. This is the size of nucleus. Big as 10 power 26 meter. This is the size of universe. Okay, the size of universe may differ according to present time. Present time, the universe size is 10 power 26 meter. Then ranges of mass. Mass is small as 10 power minus 30 kilogram. This is the mass of electron. Big as 10 power 55. That is the mass of universe. Okay, weight, right? Mass means weight. Weight of universe and weight of electron. Then mass of time. Sorry, range of time. Small as 10 power minus 22 seconds. This is a lifetime of elementary particles like neutron. Neutron, this thing will die soon. Okay, die very soon. Big as 10 power 18 seconds. Time ranges big as 10 power 18 seconds. This is the lifetime of universe. Okay, we have learned the ranges of length, mass, time. Okay. Small as 10 power minus 14. This is the size of nucleus. 10 power 26 meter. This is the size of universe. 10 power minus 30 kilogram. This is the mass of electron. 10 power 55 kilogram. This is the mass of universe. Then time, 10 power minus 22 seconds. This is the lifetime of elementary particles like neutron. And 10 power 18. This is the lifetime of universe. Okay. Now let's see the fundamental forces of nature. Okay, fundamental forces of nature. So force, we have 4 fundamental forces of nature. They are gravitational force, weak nuclear force, electromagnetic force, strong nuclear force. So here the strongest is strong nuclear force and the weakest is the gravitational force. Its relative strength is 10 power minus 39. So it is the weakest. Its range is infinite. That is, it's a long range force. Its description is between all objects which has mass, attraction, force, weakest force. Okay, its description, that is, it will be between between objects which has mass. They will have attraction, they will have force, they are the weakest force. So gravitational force is inversely proportional to 1 by r square. Okay, 1 by r square. So here r means distance between two objects. Understood? Okay. Then weak nuclear force, its relative strength is 10 power minus 13. It is very short. Its range is very short. This weak nuclear force will be between elementary particles like neutron. Here, the between page even we have learned about neutron. It will die soon, right? Yeah. It will be between elementary particles like neutron. Next we have electromagnetic force. So its range is, relative strength is 10 power minus 2 and its range is infinite. As gravitational force, its range is infinite, long range force. Its description is, this electromagnetic force will be between charged particles. This can be attractive or repulsive. Okay. This electrostatic force is inversely proportional to 1 by r square. I think here I have told inversely proportional, right? Gravitational force is inversely proportional to 1 by r square. Inversely proportional to 1 by r square. Next we have strong nuclear force. Its relative strength is 1. Okay, its range is very short. This strong nuclear force will be between nucleons. that is between protons and neutrons. This strong nuclear force will be between protons and neutrons. Okay, this is all about fundamental forces of nature. We have learned about gravitational force, weak nuclear force, electromagnetic force, strong nuclear force. Okay. The next topic is conservation laws. Let me write this and teach you so that you can understand very easily. Conservation laws. So let me take the example of tap. Okay, there is a tap, and this tap, that water coming from inside is potential energy. Okay, it is what? Potential energy. The water is coming like this, right? And it falls in a tub. So it's coming, right? The water is coming. So this energy, the potential energy, will turn to kinetic energy. Again, the water is coming to rest. Then it again becomes potential energy. So here what is actually happening, guys? No energy is destroyed. The energy is that's changing. None of the energy is wasted. We did not destroy energy and we did not create extra energy. We converted one form of energy to another form. Am I right? Yes. The energy is constant here. Correct? Yes. So there are many conservation laws. Okay, there are many conservation laws. Let me name some of them. Conservation of energy mass, conservation of energy mass, conservation of momentum, conservation of angular momentum, okay, this is all about conservation laws. So guys, the one shot video of the lesson the physical world is completed successfully. Let me complete this video by telling that I have a Telegram channel, common channel for everyone, and particularly for class 10 students I have another channel. There I will be uploading my class 10 notes. Okay, it will be helpful for class 10 students. So if you have any small brothers and sisters who are studying in class 10, please inform them about my channel, my Telegram channel. So okay, that's all about this video. Thank you. Please subscribe. It means a lot to me. Okay, thank you. Bye bye.